Hello, welcome to the presentation about 10.5 and what's coming next. Let me introduce myself. My name is Sergey Golubchik and I was adding features to MySQL since 1998, and since 2010 I'm working on MariaDB. Now I'm a VP Server Engineer in MariaDB Corporation and a board member of MariaDB Foundation. So 10.5, main facts about it. We started working on 10.5 in May 2019, and in about a year we released a first J release, and as usual it will be supported for 5 years, so it will reach end of life in July 2025. In my opinion, the largest 10.5 feature is column store, so let's talk about column store. Column store is a storage engine for analytical queries. Imagine an analyst sitting at his laptop and cutting and slicing the data in various ways and grouping them and joining and ordering and stuff like that. This usually means static, mostly read-only data. This means complex select queries. And that means that you don't really know in advance what the analyst will do. So you cannot actually pre-create indexes in advance to optimize for his queries. And this is exactly the use case for column store. A bit of a history. Column store is not a new engine that we just quickly whipped up last year. It was under the name InfiniDB. It was developed by Calpont since 2000 to 2014, according to Wikipedia. And under the name column store, it was developed further by MariaDB Corporation since 2016. And now it had reached a step where it could actually be added as a pluggable storage engine into MariaDB server. A word of caution, because in MariaDB plugins can have independent maturity levels. MariaDB 10.5 is GA, it's stable, but column store is at the moment only Gamma, but it's still quite usable and hopefully it'll be GA quickly. So what is column store? As you might have guessed, is a columnar storage engine. That means that values for all columns are stored together, all values for one column are stored together, as opposite to, for example, in a DB where all values for one row are stored together. This works very well for analytical workloads where the tables are often denormalized with hundreds of columns, but you only want to look at a few of them. If you store separate columns, separately, then you only need to read the data for those columns that you are interested in, significantly reducing the I/O and making the queries faster. Also, storing all values for one column together makes compression a bit easier. So 10 times compression in column store world is not something unheard of, it's typical. And also column store has some kind of indexes or index-like structure for those columns. You don't need to create indexes explicitly. In fact, column store doesn't even support explicitly created indexes. It kind of automatically indexes everything all the time, which is exactly what you need for analytical use case, because you cannot pre-create indexes in advance, as I just said. So column store fits this one very well. You can modify your data with insert, update, delete, but as it's again usual for analytical databases, column store has a fast bulk data loader, which allows you to quickly load a huge amount of data into column store by passing a SQL interface directly into column store. And as it's not very usual for analytical databases, or was not, column store can easily scale horizontally. If you have lots of data, more data than your workstation can handle, you can add another storage node and then yet another storage node, and then you have a storage cluster of nodes that your MariaDB server will be talking to. Also, you can add another MariaDB and yet another MariaDB, many MariaDB nodes talking to the cluster of storage nodes, so you can scale both on the MariaDB level and on the storage level. Column store is a really huge thing, and it deserves a talk on its own, and deserves many talks on its own, and we don't have time for that. So this is the URL to the knowledge base. Read the manual if you want to know more about column store. Another new storage engine in 10.5 is the S3 storage engine. It's designed for inexpensive, reliable storage of archival data. Like, imagine you have some financial transactions, or I don't know, some visits to your websites, user clicks, ads, advertisements that you show, and you store your current data locally in your data center, and then you also need to provide high availability, redundancy, and stuff like that. And data for previous months you can upload into the cloud, into Amazon S3 for example, and then you'll have rather inexpensive and quite reliable storage of your archival data, and you can work with your infrastructure on your actual data that you modify all the time. So, as again I've just said, S3 storage engine stores data in Amazon S3. It can also use any other compatible storage that uses S3 compatible API. The data in the S3 engine are read-only, so after you upload the data into S3 you cannot change them anymore, which is fine because those are historical data that do not change. And S3 allows shared access to the data. You can have many MariaDB servers accessing the same set of S3 buckets, so you don't need to duplicate the data if you want to access them from multiple places. Again, there's a knowledge base page about S3 storage engine. There's also a Percona blog about it. You can check both if you're interested. Now, what new SQL features were added in 10.5, well, on SQL layer? I'll start with small and simple features, and then I work my way to the more complex ones and that I explain on following slides. First, our database can now have comments. Though it was a contributed feature, there was a pull request. It's not something we developed internally. You can create and alter database with a comment clause, or you can use show create database to see the comment. All the table can now rename columns and indexes. That also should be pretty easy, pretty clear. Select uses set operations like accept and intersect since 10.3, and now they can also support the all qualify, not only distinct. This is SQL standard feature, and it was developed again not internally but during the 2019 Google Summer of Code project. Google Summer of Code student implemented it for us. Another 2019 Google Summer of Code project was insert returning. With returning clause you can return a result set from insert that contains the data you have just inserted. It's particularly useful if you insert lots of rows and you want to know generated auto increment values. You just add returning and the auto increment column name, and whatever auto increment values were generated, you can have them as a result set from your insert. If you use recursive CTEs to traverse graphs, you definitely have faced the cycle avoidance problem. Now it can be solved more robust and faster with the cycle clause. And if you use application time period tables, we now support with overlap standard constraint, and more about it on following slides. So cycle. This is an old example of the recursive CTE from our recursive CTE knowledge base page. If you want to see the complete example, go to the knowledge base, but it basically has a table of the US city names and another table of bus routes between those cities. And this recursive CTE shows all the routes starting from New York. So first select New York, and the second one recursively appends the current city to the current path, and locate condition. It rejects cities that are already present in the path to avoid cycles. So there are a few problems with this approach. First, as you can see, after finding a perfectly valid route from New York to Boston, it also suggests to go from New York to Boston via Washington, which nobody really does, 3 times as long, and so it's kind of a useless path that we don't really want to see here. But this is a minor annoyance. The major problem is there's a bug here in locate. Let's say we also had, besides New York, Washington and Boston, we also had Moreno Valley, California and Reno, Nevada. This locate thing would find substring Reno inside the city name Moreno Valley. It would think that the bus has already been to Nevada, even though it hasn't. So this is just plain bug, and this is the old version of this recursive CTE from the knowledge base. In the latest version I fixed this bug, but there is no completely foolproof way to fix these string searches. They are inherently buggy, inherently problematic, and also they're slow, particularly if you have long paths. Then the string searches all the time. This is just slow. This is what 10.5 fixes. See, this query written, it removes locate completely and uses cycle clause. So it doesn't invent any more creative ways to go from New York to Boston via Washington. It doesn't show this long path after it has found the short path. And also it's faster and it's bug proof as compared to the string searches. Now, as for without overlaps, let me first describe the use case here. Imagine this hotel booking system. So that's a table, it has hotel rooms, it has guest names, his check-in and check-out dates. And then we insert some data here. Alice checks into room 11 in October 1st and checks out on October 3rd. Then Bob will take room 12 from October 2nd to October 5th. And then Carol will take room 11 after Alice checks out from October 3rd to October 7th. And then Dave will check room 12 from October 4th to October 6th. And now if you following the dates, you would have noticed that there's a mistake here because Dave cannot check into room 12 because Bob didn't check out yet by October 4th. And with 10.5 we can make the database to check this constraint for us. First we need to declare this table an application time period table by creating a period of those dates. This way we tell the database that those two dates they considered a time period. This was possible in 10.4. In 10.5 we can add a new constraint. It's unique constraint for room numbers and a period without overlap. That means that either periods should be without overlaps or room numbers should be unique. If two rows have overlapping periods, then those rows should have different room numbers, which is exactly what we need here. And if you would try to do those inserts into this table, you would get a duplicate key error, which is basically exactly what we need here, because Dave can check out in the room that Bob didn't vacate yet. Now, one of the most user-visible changes in 10.5 was the splitting of super privilege. Super is a quite historical privilege that existed for maybe 20 years. Over time, it accumulated all the different commands and activities that didn't quite fit in any other privilege. So it became a security nightmare because you cannot grant anybody fine-grained access to do something. You have to grant the whole super that allows the user to do lots of kind of things. So we finally decided to bite the bullet and split the super into logically grouped activities, and every activity got assigned a separate privilege. For example, binlog monitor allows you to do show commands related to binlog, like show binlog status, show binary logs, show binlog events. And set user allows to change definer of stored routines and views. And I'm not going to describe every single one of them because, again, you can just check the knowledge base here. There were features that we have added to add more visibility into what MariaDB is doing, what's happening internally. And one of those features that was requested for quite a while is better performance schema support. More MySQL compatibility in the area of performance schema. We have added a lot of new performance schema tables to 10.5, making it basically MySQL compatible here. So if you have an application, some kind of monitoring application needs performance schema, it'll probably work with MariaDB out of the box. There are a few tables that we don't support yet, and we are working on supporting them. I'm not going to talk more about performance schema because there will be Valery Kravchuk's talk about performance, and he'll talk about performance schema in MariaDB. Also, we've added more tables to performance schema through information schema, providing more visibility into what thread pool is doing, and more status variables that describe various aspects of InnoDB, like memory consumption, net logs, again, exactly for this very reason, to provide more visibility into what InnoDB is doing internally. So now from performance schema, let's segue into performance improvements. Those are important performance improvements on the SQL server level. So until 10.5, you would do an order by, I don't know, varchar 300, then every sort key would take 300 bytes in memory, and if you use UTF-8, it would be 900 bytes. And so starting from 10.5, sort keys would only take as many bytes as the actual value takes, which means that usually MariaDB would put a lot more keys into one sort buffer. It would need to write much less data to disk, so the queries will be faster. How much faster? That actually depends very much on your application. In our benchmark, we have seen queries getting 5 times faster, and 10 times faster, and 10% faster, or not faster at all. It depends on the data type you're using, you're ordering by, on the character set. As I said, UTF-8 will get better speed improvements. It depends on number of rows on the table. It depends on how actually long your string values are. And also depends on what you're doing, what your query is doing, because if you do select star from a very huge table, then most of the time the server will spend sending data to the client, and any file sort optimization just won't be noticeable on that time. Another optimization affects everybody who needs to return numbers from the database, which I think is just pretty much everyone. In our simple select number from T1, we've seen 11% speed up by optimizing, removing unnecessary character set conversions for numbers. Now we've replaced psery regular expression library with psery 2, and if you check regex engine machine speed benchmark, if you go for that, you'll see that psery 2 could be sometimes slower. When both psery and psery 2 are fast, then psery 2 can be a bit slower, but usually it's faster. Sometimes can be 7 times faster if you do lots of OR operators. Depends on your regular expression. And by the way, note that all those improvements, they affect both single thread performance and multi-thread performance. It's what happens quite often, that if you want to improve high concurrency multi-threaded benchmarks like Sysbench, then single thread performance basically goes down the drain. This is not the case here. All those improvements, they both improve single thread and multi-thread performance. And also parallel replication now is optimistic by default. It means the slave will try to parallelize as many transactions as possible, not following any more master concurrency. The slave will have a much easier time to keep up, even under load. So these were performance improvements on the SQL layer. There were also lots of improvements on the InnoDB layer, and I'm not actually going to explain them all. I just listed some of them, because there will be another talk by Marko Mäkelä who will talk about scalability improvements in InnoDB, and then he'll be talking about all those InnoDB improvements. So just watch his presentation if you're interested. Now, there are a few features that don't quite fit in any of the previous slides, so I'll just list them here. All the binaries were named to use a consistent naming pattern, MariaDB-something, like MySQL dump was renamed to MariaDB-dump, and MySQL_upgrade was renamed to MariaDB-upgrade. But there are symlinks to all names, so all the scripts and all applications will continue work as before. You don't need to change anything. But the plan is in the future to make those symlinks optional. So this is interoperability feature. If you don't want to install those symlinks in future MariaDB version, then you will be able to install MariaDB and MySQL in parallel if you would ever need to. We've added a new data type called INET6, which stores, not surprisingly, IPv6 IP addresses. Note that it doesn't just store them in strings, it stores them as 128-bit byte numbers. So the first 0 that I've inserted, it's stripped, and the number is printed in the IP address is printed in the canonical form. You can also see actual bit value, numeric value of the IP address, IPv6 address if you want to. But what's actually important here is that we didn't just add a new data type, we added a new plugin type, a new infrastructure for pluggable data types. So now it's much easier to add new data types, and you'll see more pluggable data types added in the future. You can add yourself more data type plugins if you need to in your application. If anybody still downloads binary tarballs, you'd appreciate that they become much smaller. And if you're using system versioning and you care about performance, then you probably partition by system time to keep history separately from the current data. And typical partitioned table look like it has one current partition and one history partition. Because this is such a typical use case, we simplified it, and you no longer need to specify partitions explicitly. The MariaDB server will do it for you. You just need to specify the table's partition by system time. If you want to have more than one history partition, you can do that too by just specifying the number of partitions, which is particularly useful if you want to rotate history by time, for example, like in this table structure, where every month of history is stored in a separate partition. There were other features, but we are running out of time, so I'm moving to the beyond part of my talk, beyond 10.5. And beyond 10.5 is, next release version is 10.6, so let's have a look. 10.6 facts. The 10.6 development branch was created in May 2020, but actually some of the features were in the development long before that for many months already. So it's not like we just only started working on 10.6 4 months ago. Now, I don't have a crystal ball, I don't know what will happen in the future, but if you look at other MariaDB releases, then they usually become GA somewhere in May, June, and they are usually supported for 5 years after that. So probably 10.5, 10.6 will be GA in May 2021, and it'll probably be supported until April 2026. But of course, I don't know. As usual, development happens all in public. So this is our Jira. You can search for yourself. You can search for fixed version equals 10.6 and see all the issues which were considered for 10.6. There are already, as you can see, almost 200 of them. So we definitely won't be able to do them all, and I'm not going to talk about them all. But this is my personal, highly subjective top 7 list of all those 197 features. The first one is, of course, the cross-engine alter table. This is something I wish we had quite a long time ago, and lots of users wanted it. It's when you alter a table and you can see it still continues to be writable until the alter operation finishes, and that's independently on what kind of alter you do. Even if you do it between different storage engines, you can still keep using the original table until the alter operation is done. Second one is atomic DDL. I don't quite need to explain that. I think atomic DDL is pretty clear, and it's a feature that you don't usually need. You only need it when you have a crash exactly during DDL, but when you do have a crash during DDL, then things can get pretty ugly. There could be data corruption if you are very unlucky. And with this MDEF implemented, then you cannot, because no matter when the crash happens during DDL, it cannot have data corruption or data loss. Keep sending metadata in binary protocol. It would be useful for anyone who's doing short selects, like point selects, and using a relatively modern connector that uses binary protocol. Because in this case, the metadata is sent twice, and it could be up to 3/4 of the actual data. So by skipping unnecessary metadata, we can send a lot less data over the network, and again, have the whole query round trip much faster. And another interesting feature would be agent support for JSON table. If you don't know, it's presenting JSON as a table, so you could do select from and then JSON. It's a SQL standard feature, and Oracle and MySQL both have them, and other databases. And users were requesting it. We are planning to have it in 10.6. Don't open partitions included by partition pruning means that if you have, you'll appreciate that if you have a table with lots and lots of partitions, maybe system version, I don't know, and you only need data from a few of them. Currently, MariaDB opens them all, but not open, I don't know, hundreds possibly of partitions that you won't be even looking at. You can shave a lot of time from the query execution. Executing DB crash recovery in background means that, if you have a crash and then after the crash, MariaDB will start faster, it'll be serving queries earlier, and it'll continue in DB recovery in background. And the last one is, remember I just had a query, I just had a table structure with partition by system time, interval 1 month, 12 partitions. I get 12 partitions, and every new month of history would be going to the new partition. With this, when this feature would be implemented, I wouldn't even need to create 12 partitions, because every new month, MariaDB would automatically create new partition for the history. So it would make managing of partition system history tables much easier. But 10.6 is not only about new features. About half of the tasks are about refactoring. They are not generally user visible, but they improve code stability, they reduce number of bugs, improve maintainability, and quite often they improve performance too. I listed a few examples of those refactoring tasks from 10.6, but I'm not going to describe them. Talk to me on chat, write emails, check Jira if you're interested. So this is what we are working on in 10.6. But hey, you can participate too. You can suggest new features, for example, for us to do in 10.6. But yeah, you need to understand that there are already almost 200 issues and we won't be able to do all 200 anyway. So if you suggest a feature, it could just happen that it'll just fall below the priority level and just won't quite make the text, won't quite make the 10.6 deadline. Or perhaps your feature will be so awesome that we will decide to do it, absolutely do it at the expense of some other feature, then we remove some other feature from the 10.6 plan and we add your feature instead. So you can request a feature and you will see on Jira and you will see what will happen. Perhaps there's a feature that you definitely want to have implemented, and we decided that it doesn't quite make the line. You can just go and implement it yourself and create a pull request. As you have seen on previous slides, we accept pull requests, and if it's good, it'll be in 10.6. If you just want to get your hands dirty and help us and implement something in MariaDB, but you don't have a personal itch to scratch, look for beginner-friendly label in Jira. It marks tasks that one can implement without prior experience in MariaDB source code, so even junior developers can usually do them. So talk to us. You can talk to us on Zulip, you can write a mail to Maria Developers list. We are always ready to help.